Good afternoon and welcome back to Dr. Logic Awkwardly Does Logic. You may remember that when we introduced the rule of uniform substitution, there were two things that we said very specifically. One is that the only thing that you can do the substitution on are atoms, and you have to do it on all of the atoms. Anything else, and you don't have a legitimate occurrence of uniform substitution. The new derived rule that we're going to talk about in this video gives you a way of doing substitution that doesn't have to be uniform, and it doesn't have to be on atoms. However, what it does have to be is, instead of replacing an atom with any arbitrary formula whatsoever, we will replace any subformula with anything that is equivalent to it. So if we have, for instance, P, we could replace it with not P. And we could do this at any points in the formula, and not for all of the P's, only for some of them. Or if I had, if P implies Q, I could replace this with not Q implies not P. It's contrapositive. And I could do this anywhere in the formula. So unlike some of the other rules we've looked at, uniform substitution of equivalences doesn't have to be applied to the main connective. It can be applied to any subformula. And I've lost my train of thought, but that's okay, because you've got the important bits of it. You can substitute things which are not atoms. You don't have to do it uniformly. You don't have to do it on the main connective, so long as the thing that you're substituting in is equivalent for the thing you're substituting out. So with that, let me just bring up the whiteboard so that we can write all of this down, so you've got all of the details and you don't have to rely on my sometimes slightly skewed statements. So the rule, substitution of equivalences, and this is often, sometimes it's often called substitutions of identicals, but the things aren't really identical, they're only equivalent to each other. But we will abbreviate this as subs ID or subs equiv, so that it's clear that this isn't uniform substitution that we are talking about. So the rule is defined formally as follows. If you can prove some formula phi, and you can also prove, so this is provable equivalence that we are requiring, that some formula chi is equivalent to some formula psi, and so, yeah. And then some other formula gamma differs from phi only in having psi in some places, not all, just some, where phi has chi, then you can prove gamma as well. So you are allowed to write down essentially the result of the substitution instances. So if chi and psi are provably equivalent, then if we take a formula that we've already proven, some theorem phi, and replace some of the instances of chi with the thing that's provably equivalent psi, and the resulting formula that we get from doing that is gamma, then we can also prove gamma. So just to kind of reiterate the two important points. So you don't have to substitute all occurrences. So this makes it non-uniform. That's why it differs from uniform substitution. And the other the other thing that makes it differ from uniform substitution is that you don't have to do the substitution on atoms. So I'm just going to give one example so that you can see how this works. So we already know that, so for any modal system based on propositional logic, we know that not phi is equivalent to phi. And this is something that we can prove because it's just a substitution instance of a propositional tautology. So then suppose that we are able to prove phi implies phi or psi. Then Substitution of equivalence allows us to derive the following. We can then have not phi implies phi or psi, or we could have phi implies not phi or psi, or we could in fact do the substitution on both of them if we wanted to. So there's nothing preventing us from substituting uniformly. But there you go. These are all legitimate applications of the substitution of equivalences rule. We'll look at some more examples, and then we will go and show why this is an acceptable rule to have, even though it violates all the things that we said that we need to have about substitution. We'll do that in the next video. So until then, take care and see you later.